Hello, and welcome back. I hope it's still working. I think it should. Last time we changed our main project back to Angular and the front end instead of the back end because at least for me, I didn't get how the HTTP request and response will be like. So it's not like I have some issue with the back end, but my lack of understanding of the front end is the reason behind that. So we went with TypeScript so that we can use it to Angular, but apparently TypeScript isn't that difficult. I mean, it's just an extension to JavaScript, but what are the main concepts to know TypeScript? I know it is used for type safety with JavaScript, but that's about it. Allows you to specify types for variables, yes. Instead of writing let, you can specify what inside the letters. Explicit typing, inferred typing, and then interfaces. Yeah, I remember that, creating an object and then creating the instance variable for it. It's similar to Java, so it's not something new. Classes and inheritance, also some other, also generic such as Java thing. Enums, types aliases, a new thing. Union intersection types, not sure what that is. Type guards. So it seems like there are some concepts that I do know and some that I don't, and I mean 15 concepts isn't that much. So the channel that I decided to choose is this one because I think he probably does the most. He's the type of person that gets only the key concepts and not every detail, and that's how I'd like to learn, so we will go with him. Make a function into a TypeScript function. Function make turtle crawl. Just need to revise myself. How did we write functions normally in Java? How you write functions in JavaScript, because it has been a while since the last time I used JavaScript. Traditionally you say function and then yes, okay, and then you get it inside the const. That's the one that I'm most familiar with. And then yes, there is the arrow function, which is the one that I'm also familiar with. That's why this one seemed a bit alien. I never used it. Okay, forget all of the other stuff. That seems like it. Knowing, being familiar with the arrow function and not the normal function seems weird.
Well, number one, it's kind of ambiguous, and it's ambiguous in many ways. Like, make turtle crawl. Where are you making turtle crawl to? Why are we talking about turtles when we're talking about computers? Mainly just for a simple example and to try to, make things funny so that people pay attention, but it is a pretty bad function because you are being very ambiguous. Like, what are you passing? Like, what is a crawl? Like, why are you just
what type is it? Yes.
And just for the most simple example that we possibly can, we're just going to pass it this parameter in as it is.
Console log is.
The thing to realize about parameter annotations, or just functions in TypeScript in general, is that there's two things that we can do to kind of soup this thing up. We can add type checking to the parameter, sometimes called parameter annotations, and we can also add type checking to the return type.
Like normal languages, yes.
It's really important to be specific about what you are putting into functions, and it's also very good. No, it's not even very good. It's absolutely crucial that you be specific about what you do when you put things into functions and what you return out of functions, because what you put into a function, or what type of data that you put into a function, how this function performs, how it actually
Yes, very ambiguous.
Is if you've ever been programming and you saw like this weird object thing. You may have seen this. I'm pretty sure if you've been programming for any amount of time, you've seen like this weird like object looking thing. And if you ever see this, it's because you are not being cognizant or aware of what type of object that you are putting into your function,
You know,
or what
exactly.
type of thing that you're putting out of your function. I'm going to show you why this occurs and how this can be, you can outwit the compiler. That was very over the top. Outwit the compiler with type checking. So what you want to do is you just want to look at this and be like, well, obviously because it's a console log, I'm going to be console logging a string because I'm not going to be console logging numbers. And then that will help us take care of this part. And the only thing that you need to realize that when you are defining the type that you are going to put into a parameter, all you do is you add that call. Okay, so
it's simple. It's not that hard. Yes.
We'll take, like, now you said the parameter is important. What about the return? Like, what do we need to do about the return? Okay, so really simple. The only thing you do, put colon right here, and then your return type is going to be string. And I know there's other people who are saying, no, Teddy, that is not right. I know, I'm just trying to see if people are paying attention. It's not going to be string. Why is it not going to be a string?
Because it's console log doesn't give a string. Yeah, it's like a void in Java.
This is wrong. Let me get my pen here. This is wrong. Wrong. Actually, I'm going to see if I can make this red. Just to emphasize, this is wrong. And I've never actually used the red. You are the weakest link. So what's happening here is console log is actually you're mutating. This function is impure. You are mutating something on the outside of this function. You're not actually returning anything. You are going into the computer's console log.
Just typing it again.
To console log something, and therefore you are not actually returning anything. What we are actually returning, what in the hell? What we are actually returning is we are going to return a void.
Yes.
You may have seen this before.
In Java, at least, yes.
A void is common in Java. Public static void main. So we're going to void.
The cancel statement, yes.
Then it will be okay. Then, because you're not actually returning anything. Void means you're returning void.
Nothing.
Let's just say that I want to actually return a string. Like I really want to return a string. Well, we have to get rid of console log first.
Of course.
We actually have to
return value. And then you have to get rid of the void also.
Just like that. And then when we do that, that is when we can actually return a string. And our function will not yell at us. But let's just
okay, optionals, of course.
You are a rock star. You want to take it to the next level. We're going to talk about explicit, inferring a return. We're going to talk about void. We're going to talk about explicit. So optional is going to be the most confusing, so I'm going to save that for last. We've already kind of talked about void, so let's talk about inferring a return. Okay, so let's just say you are very lazy and you want to get rid of the string. What do? You just get rid of it. TypeScript will infer the type just like it does with variables.
But it defeats the purpose of type checking.
It can also infer this as well too. That's within the parameter. TypeScript is smart enough that there's very awesome and I don't know how any of these algorithms work, by the way, and I really wouldn't suggest you go out and learn them, not unless you are going to be designing like the TypeScript compiler. But there's algorithms underneath the hood in TypeScript that
detects, yes,
figure this stuff out
if it's string or not.
A lot of the time it will infer it. It's basically TypeScript just saying, hey buddy, you just kick back and relax, and we're going to go ahead and we're going to take care of this for you. You don't worry about a thing. Okay, so void. We've already talked about void. Void just means you're returning a console log, or you are You could also do it too, like if you had a function outside of the program, like let's just say make turtle start. You have to start the turtle up like a machine, and then you have to execute that function. That's another because you're not actually returning anything. That's another
void,
example
yes.
when you would use void. And because we also have decided that we are going to have a return type, this is what explicit means. This is an explicit. Whenever you're being explicit, this word is very fancy word.
What it means specific?
All it means is that you're actually specifying.
Exactly.
And
exactly, yes.
Itself is just you being explicit, and it's very important because you're going to hear that word a lot in your career. People are going to use that word for a lot of things because
you need to use it, yes.
To really describe a lot of things. You're just being explicit. You're being very particular about what you're trying to say. Okay, so optionals. This is the granddaddy. This is pretty important.
Oof.
Because you're going to come. Optionals are going to be everywhere in the real world, and
yes.
a lot of times people don't really explain optionals that well. So, an optional. Let's go back to the console log. Please stick around for this one. This one is important. Okay, so crawl.
I'm surprised by how much we use actually option, but like option.
What if, for some reason, you just wanted to execute make turtle crawl without anything inside of the parameter? You don't want to put anything in here. So let's just say you go into Visual Studio, you boot up Visual Studio, and you just execute it like that. You hit the green button and you execute make turtle crawl, and you think that this is perfectly fine because not passing anything into it is perfectly fine.
Yes.
And then your whole entire program breaks. Or I think it'll still console log. I think it'll still run, but the program nonetheless is running in a way it's not supposed to. So if you want to give your functions the option to be able to pass in stuff without anything in it, if you want to make it optional, that's what an optional is. You're giving the parameter the option, or the
interesting.
property. You're going to give it the option.
So the way that they write optional here is by adding a question mark, not two pointed brackets like Java. How do you write optional in TypeScript? Okay, I see. Actually, let's try to const. What do we call a function? Is working. Then we say out the two brackets. We say just working. We have the arrow function. Then we say that this one is optional. Working is declared, but it's never read. Okay, we can just type here console.log, and then we can say working. So the optional also means any. How about if we say string? So now we specify the type, but optional properties. Is the optional typing means any. Is not does not mean the same as any. There are two distinct concepts. When a property parameter is marked as optional modifier, it means that the value can be undefined or absent. So it can be empty or it can hold something. Any type means that the value can be any type. It could be string, number, or anything else. Any essentially displays type checking for value. Okay, so that's any, but that's optional. Oh, okay. Let me check if this correctly. So any means that it can have any type but not undefined, but optional can have a specific type or undefined. But we can still use any with the option at the same time. Any means that the variable can be assigned any value of any type, string, number, object, or even unidentified or not. When you use any TypeScript, essentially stops performing type checking on that value. It doesn't enforce any constraints, so the value can be of any type, and it could be undefined also. Okay. When you mark a property or a parameter as optional, it means that the value could be a specific type or undefined. Let me get my trusted whiteboard. So basically what any is, we have here optional. Any is anything from all the category of variables we have. But optional can be only two: the specified type or the undefined or not. Or here can be number, can be string, can be boolean, can be anything. Okay, so I think using any would be a bad practice, because if you're using TypeScript to check on the type of the variable and you use any, you're basically getting rid of that feature. So I think that's something I'll probably stay away from.
And that's what this little question mark is. A question mark is, like I said, it's just there to give you the option. You don't have to pass anything in if you don't want to. And most of the time, it's going to come in conjunction with a type check as well.
Yes, that's what I said. And you can actually conjunct it also with any, but
parameter annotation. And
but the syntax goes like this: the optional part would be with the variable itself, not with the type. And with the type here, we can also have any with the optional, and the optional works the same way as in Java also.
That's like a really good introduction to functions. If you guys enjoyed this video, make sure to hit that like button. What's up, guys? This is Teddy. Welcome to my YouTube channel. This video, we're going to be talking about one of the most underrated ideas, topics, things in the world of programming, and that is going to be the concept of objects.
Okay.
Once you can fully wrap your head around objects, what they are doing underneath the hood, how they differ from primitive types, like so let's just go ahead, let's do a brief refresher. I think it's really important that we just
Yes, we need a brief refresher because I forgot how to write an object in JavaScript. So you say constant person and then you do it like this. That's the way I remember it, at least. And yes, you can also, if I remember correctly, add a specific method inside of it, or you can make an object inside an object. Okay, I get the gist of it.
Talk about something very important. That is the difference between a value type and a reference type. And I'm very infamous for wanting to literally beat into people's heads. What is the difference between a value type and object?
If I remember correctly, one is registered in the specific place in the memory, while the other one is registered. Okay, not sure if I can explain that well, but basically, if this is the memory address, there is two: one that's very small and one that's at least big. For the primitive type, what else? We have two types. I forgot the name. Let me check again. What are the two types you can assign to a variable based on memory? Yes, primitive types are the ones that are very small and they can be assigned here. For example, string, I mean in Java it's not, but apparently in JavaScript it is, and then we have numbers. But for these are primitive types. The other one is called reference types. It's also used here, but it's used as a reference to the address that's mentioned here. So it's a two-step program, while this one is a one-step program. And reference type. Let me check if you agree with that or not.
It's called an object type in...
Yes, one example for that would be objects or arrays. I know JavaScript tuples also exist, but I'm not that much familiar with it yet.
TypeScript, but sometimes it is referred to as a reference type. Object, value, object. So a value type is going to be things like a string. And
again, that's not the case. Yeah, string is not.
A string is actually an object type in...
Yes, it's actually a string. That's why you write it in capital letters, for example. The first letter, I mean.
We have... I'm trying to think what else. String and a number are good for now. In object type, we have
arrays, tuples, objects.
Obviously, object is going to be more than likely what you're going to see. I'm going to say it's about 80%. About 80% of your life in software development
will be around objects, yes.
Even JavaScript, for that matter, a lot of it is going to be objects. And C# and Java and TypeScript, it's going to be even more. So pay extra attention to object. Even over string number, if you can understand an object and really understand it at a base level, it will help you dividends. It will pay dividends. So
I think I do, but let's check.
Between in a compiler, really low level underneath the hood. I'm assuming
how is it stored in the memory addresses?
You're probably professional. You're probably somebody who likes to understand things at a deeper level. The difference between a value and an object type is where they are stored in memory. A value type is stored on the stack.
Like I said.
The stack is designed for data structures that don't take up much space. It's the popping, the tennis ball canister stack. If you want to know more about a stack, you can Google it. I have a whole course on data structures and algorithms in C#.
I think I'll take that one later, but
that object is stored on the heap because
I'm familiar with the term, but I'm not sure what does it even mean. I haven't passed my operating system subject yet.
You're talking about an object with, so pretend like every single part of these, this is like a giant conceptual object, and then there's a string in here, there's an int in here, there's an array in here, and even there's if there is another object in here, sometimes there's a list, and then there's list of, and objects can literally be like they're almost like Excel spreadsheets on steroids, and there are Excel spreadsheets that have Excel spreadsheets
make a type to an object because it's literally can be a different combination of all types.
Get a little carried away here. We're not gonna be talking, about stuff that's that complex, but just remember where things are stored in memory, and think of objects as almost like Excel spreadsheets of computer data. They're just there.
Actually, that's a good analogy to have in mind.
Primitive types. Objects are there to keep all your primitive types together. So look at this one. Very simple example. This object is going to have a name, and this name is going to be a string. This is a string.
Yeah, that way of typing, I'm not familiar with it. How do you write an object? I'm familiar with this one. Why do we write an object like this? And let me check how did he write it. Const beaver, for example, and then he had double with yes. And we have here, for example, tail, and then we have string. Okay, I forgot they don't use it that way here. You actually have to specify detail. The colon is used to define the key value pairs to an object. It's not valid syntax, but I forgot the comma is not the comma, the space. Seems as even ChatGPT is telling it's wrong. Okay, let's check what you would say more about it.
And this is Boolean. Those are the only two properties in our little Excel spreadsheet here that we're going to have to talk about. But what about in TypeScript? What does this have to do with TypeScript? We can take objects and we can apply the same type.
Okay, yeah, that's what I meant. Usually in Java, when you create an object, you create them first by specifying the blueprint basically for them, and then you add second. But in JavaScript, no, you just, it's unga bunga everywhere. You can just make the objects and add it immediately. And TypeScript introduces that function, which, yes, you can specify the data types that goes in it. You have function and you have print beaver.
Type annotations, but we apply them with objects. And let's just put const beaver over here. We're going to print a beaver. We've got our beaver object, and its property is cute because all beavers are cute. And one day I'll show you guys, Cornell University has a picture of literally a basket of baby beavers, and it's literally the cutest thing, and I use it in my Angular course. So if you want to check out my Angular course, also make sure to check out that. So
we will do after that course.
How are we going to make sure that we are only passing in?
So this is the function, and then we have the class beaver, and then we specified that the name will be a string and execute will be also a string. So this is the input, and then we have a return of name and execute.
This type of object that we have right here. Remember,
this one has cute as true.
So how are you going to provide, or how are you going to make sure that this type of object can only be passed in to this function? And this is kind of confusing you. Without this is where all of the magic of TypeScript is going on. This is where this is where the guardrails are coming out. This is where TypeScript is making sure that you are only passing in a beaver object, and it's happening right there, just where I underlined and where I was drawing with my pen. So right here. Don't worry about anything else, and don't look at anything else. Just kind of look right here, because this is where all the magic is happening. So another thing is that, is this function correct? Is this trick question? Is this function correct? if I run this function, what will happen? What's going to happen is it's actually going to error, because if you look, I have name and I have is cute, but notice something.
Is cute here is typed as string, and the class here is typed as boolean.
It's what's actually being passed in.
The class beaver, yes.
The actual variable that's being passed in. But this and this
or the instance variable.
It's like, what is, like, how is it going to go from this to this? Because it can't. Because you need to be aware. This is very, very important. This is something where a lot of people who are new to programming get messed up. Is you have to have your dot operator, because you're accessing an object. Before, we were previously just passing in strings. You need to be aware that we need to have beaver. We need to have dot is cute, because just by
okay, so they have it the same as Java also.
That's not going to work. TypeScript only does the type checking. It can't pull out values out of an object. Think of this as you're passing in like a little Excel spreadsheet into your function, and you are in charge of actually accessing the data in that Excel spreadsheet. The software is not going to do it for you. It doesn't understand, so you need to be aware of that. Just remember, and we're going to do an example here in a second in the actual TypeScript. Just be aware. Whenever you see the colon on the right side, and if you're in C#, it's on the left side, it's going to be type checking. Type checking is just
it's on the right, yes.
Passing in the right object. Type checking is also not going to make sure that you're putting in the right name, but it will help you autofill as well too. Okay,
acts like a filter, more or less. Yes, finally some typing. Const beaver. We say name little beaver. Then we say is cute. True. This is correct. It feels weird writing an object like that, but whatever.
Make a variable type annotation for our object. Just slow down. Don't try to think too much. Just realize variable annotation. We need to create an annotation for our object. So
double dots.
Here's a nice little trick that you can do. If you don't, and this is kind of like a hack. This is, by doing this, I call it, you're beating the system, and you're not having to actually think. I'd rather you go in here and try to look at it and assign it yourself, but if you don't want to, I'm not going to either.
Actually, everything is as consistent as I remember. So name would be like this, and then you have to add string, and then not sure if you'll add comma here, but then you'll say is cute, and then you will say boolean, for example. Saying it's wrong, then there is a comma, and that's how you add the typing.
So we're gonna go here. Remember, you want to do type checking. We're gonna have that dot. We're going here, and we want our name to always be a string. Then we're going to do the same exact thing. Is cute is going to be a string. Nope, no, it's not. I'm trying to trick you. I'm trying to make sure people are paying attention.
Okay, yeah, I was going to say it's boolean.
What is it? It's actually going to be a boolean. So go in here, we have a boolean. Now we want to go back and we want to make our print beaver function. So if you want to, you can pause it, write it down, but I'm just going to try to do it off the top of my head, and I might mess up, but
yes. We want to make a beaver function, so const. I prefer typing everything in the arrow function, so const print beaver. Let me say we have the arrow function here, and the parameter that will get this beaver. And then you have to specify again. Should we specify it or because it's already specified here? It's the clear type, but not. Oh, yeah. And then you can say probably console.log. This beaver is, now if I remember correctly, it was the $sign. Then we say here beaver dot name. Not sure how concatenation here works compared to Java, but let's see. Nope. Okay, let's check.
This is part of fun and part of the learning too. So make beaver.
If you want to make a function, you can write a function, but I'm used to making a variable.
Let's say print beaver info. So go up here, and what we can do is we can just say what do we have here for the other one. We just had beaver. We go beaver. Go up here, return.
Yeah, of course, I forgot the return because I used the console.log. So how about if we just said return? Now, how does concatenation works?
Console.log beaver info. We need to do string interpolations of beaver.
Ah, okay, it's a single one, it's not a double one. So what is the difference? I don't think it was the quotation mark, it was the other one. Yeah, okay.
Dot let me see, name, and here, and is cute. Then I have string interpolation right here, beaver dot is cute. And if you look, it's already done a form of type shifting.
Yes.
I honestly don't know exactly how it did it, but if you look here, beaver implicitly has type any. It's going to basically yell at you and tell you that you can't do this. If you want to turn this off, you can go into the tsconfig, but for learning's sake, we're not going to do that because it really will not make sense.
Yes, why would you turn a function on that you are using it specifically for it? Okay, I guess we have to specify that the name should be in type string and the is cute should be in type boolean.
And we're going to pass in the type of beaver, but it's giving us this error because it's trying to pass it in. So print beaver info, beaver.
Yeah, might as well just make it console.log again. Set end here, and then let's call the function print beaver, and let's pass beaver to it.
Like that, and it will indeed let us, but we have to tell it that we will allow any. But then again, it'll try.
Why use any? Yes.
What do we do? Oh my gosh! We have to add
the type.
We do the exact same thing that we did up top, and this is very redundant and this is very repetitive.
But it saves a lot of debugging time.
I'm going to show you guys how we can make our own class make it so that we can just type in a beaver object just like that.
I think I know how. By making, instead of adding the type here, I think by adding the type under like how Java uses it. So you can actually delete that part. Okay, I basically did nothing, but never mind. And then instead of explicitly saying what the beaver is here, we should just say it's from type string. It's from type boolean. No? Okay. It was just so I guess.
It will automatically, and we can use this in other places out of our program, because right now, I mean, this is getting very cumbersome to keep having.
Ah, okay, never mind. It was just using the interface. Okay. Forget everything I did just now.
Type this object over and over in order to provide type names. But that is going to be pretty much it for objects. It's really not that much more complicated than that.
Yeah, it's not.
In the next video, we're going to start talking about types.
Just specify the inside of the object when you are using it inside a method or a function.
Anyway, if you guys enjoyed this, make sure to hit that like button. Make sure. What's up, guys? This is Eddie. Welcome to my YouTube channel. This video, we are going to be talking about interfaces in TypeScript. And interfaces themselves
they are not the same
complicated.
with Java.
They're just sort of a weird concept. And the way that
It's used here as a type checking, if I remember correctly.
They force you to do two things. And for right now, this is probably all you need to know until you get more advanced, but they just do two things. They force you to use properties and they force you to use functions. And you may be thinking to yourself, well, why would I want
again with debugging
to force me to use something like that doesn't really make
you
sense.
don't want to get a specific type that you don't want.
And it makes sense that you want objects and you want functions and you want all of your code to conform to some type of object or type, because things can get
Yes, it's called TypeScript for a reason.
a lot of TypeScript is just having
The type assigned.
up in your code so that people can work together and not get screwed. You know, one person doesn't make a change that screws somebody else up. And let's just take this function and let's add an interface to it. And so if you look at this, is kind of like a function that's there to make you think, because there's I mean, this is correct, but if we were to do this in TypeScript, it would give us an error. And
function, yeah, because you didn't specify the type here.
one of the fundamental things that I used to get tripped up with when I first started programming is I would see objects being passed in, and I didn't really notice that they were being dotted into. And if you look right here, they're actually, we've got a dot going on. And what if I were to pass into this function a string? You know, it's not an object, and if this were regular JavaScript, it wouldn't work. So what we do, and we did this in previous videos, but I'm just going to do it again right now, just in case somebody's coming.
Specify the type again.
Video, but we would have name, and this is we're type checking the parameters here. We would have
yes.
name, we would have string. We would have
Then you have type dot string also.
And
yep.
we would have that for our type checking, because we don't have to. If you're familiar with TypeScript already, you know that we can put like another object in here, and that's what we're going to do. So if you look, it's going to make sure that we're passing.
Yes, you can have as much parameter as you want to, if I remember correctly.
Property name string and a property type string. And if you look here, force code to use properties. So we're doing number 1 right now, and I'm going to go over here and I'm going to grab an object and give you an example of something that's going to be passed into it. So we're going to go over here. I'm going to get this interface. I went ahead and made this little fake interface for you guys. So we're going to go down here. I'm going to bring this here. And what's going to happen is we're going to pass in this object up here. It's going to go down. This string is going to go right here. This type is going to go right here. And what we can do is now we can just have our Pokemon interface. So instead of having all that huge object up there, what we can have is just an interface. And I've already got a function in there. Let's take that out. So just the name and just the type. And because we're forcing this function to use those properties, if we don't use any of those properties, it's not going to let us. So next thing is functions. So how are we going to put a function in an interface? And it's the same exact thing. An interface can check functions and it can also check properties. So what we're going to do is we're going to just take one. We're going to call it
That's exactly what I was trying to do last time, but you do it in an interface. It seems like interface in Java and JavaScript have different meaning. So we say interface beaver, and we had here the name. We'll say that name would be type string, and execute, for example, will be boolean, and then you remove the type from here. Okay, I think I have to add it to. Okay, I'll need to check how.
Yell, and we're going to have it return a. Trying to think. We'll have it return a string. And what's going to happen is it's not going to let us. It's basically going to error because we don't actually have this in here. So what we need to do is we need to add, because we're having to satisfy this contract, we need to go in and we need to add this. We're going to go in.
Perfect word to describe an interface is like a contract. You need to fulfill the rules in that document.
Pokemon yell. A little bit redundant, but it's okay for right now.
You could have written it in the first console log, but okay.
Has been fully implemented, and you could see how this.
I think I can get it. So you say here beaver. How about I just change the name? We call it type beaver. So yes, you specify the type, but this time instead of writing each one explicitly, you just refer the interface itself.
Would be very important. Think if you're programming and you needed this function to be used across a code base, and you needed this in order for certain parts of your code. You need to enforce functionality. That's the reason why people call it a
contract. Yes.
If I enter into a contract with you, I am enforcing you to do something. I am enforcing you to actually uphold to my code. So let's go ahead in here and we're going to actually code this thing up and we're going to see it live in action. Okay, so first thing, we've got our Pokemon.
Yes, I like TypeScript. It makes JavaScript a bit more tolerable.
That we used in our code before, except it's set to any. So what we're
we don't want any, no.
We're gonna go interface Pokemon. Needs to be Pokemon base. And in here,
yeah, more or less like.
Because we don't have the Pokemon.yell, watch what happens. Argument of type, and you will see this a lot in real life. You're going to see a lot of is not assignable parameter type Pokemon. So what we need to do, we need to go in here and we need to implement it. So we're going to go here, we're going to go.
So everything inside the interface has to be also sent. I mean, it makes sense if you think about it, because if you are having 3, the type beaver here is for 2, and if one of them is missing, then the parameter is false, so the function wouldn't work.
Okay, so now we need to go up here and we need to actually add our function. So we're going to go up here, we're going to go Pokemon.yell, and we are going to.
I think I already know that part.
Arrow function, hold the name, so make sure that it's not an arrow function and it's just a regular function with brackets.
And even with the function here, he specified the dots. think he said something important right now.
To pass, make sure we have a return type of string, turn that into a function, and what I'm going to do is I'm going to return this dot name. It's pretty much going to be like a very fancy getter method, and if you make this an arrow function, it's not going to work because the scope's going to be off and it's not going to be able to pull the name, so make sure that it's not an arrow function.
Okay, that is a downside to using the arrow function.
With brackets. And we've got our console log, so let's go ahead in here and run this. And what I'm going to do is I'm going to step through the debugger because I kind of want to walk through it and actually see it run. I like to see things run. So go in here, we're going to go step in. Let's see, Pokemon.name, Pokemon.type first. And then we're going to go Pokemon.yell, see if that.
I have no idea how to debug actually. Probably a subject that I should get into, specifically with JavaScript.
And that is some kind of, I don't know, I don't know what that is, but our code works. So if you guys enjoyed this video, if you liked it, make sure to hit that like button, make sure to hit that subscribe.
Halfway done with TypeScript.
What's up guys, this is Teddy. Welcome to my YouTube channel. This video we are going to be talking about classes in TypeScript. Classes are, I like to give this analogy, and this is kind of, people are going to be like, holy crap, what am I watching? Okay, so imagine you don't have any drawers in your house. You just bought a house, you know, you're a software developer, you just made a code bag, whatever you want to call it, and you don't have any furniture, you don't have any drawers in your house. What would happen? You would be able to get dressed and you would have clothes, but more than likely what would happen would be your clothes would get strewn everywhere. Your clothes would be
everywhere,
difficult to keep track of. Your clothes would be very difficult to kind of keep up with. The same would be like a toolbox. Imagine you are a mechanic or you are some type of craftsman and you can't keep track of your tools. Your tools are strewn about all over the place and you are having issues, and one day magically somebody comes up with a toolbox, or one day somebody magically comes up with the concept of drawers to keep your clothes in, and that's the concept of classes in JavaScript or TypeScript or any type of language. Objects are it's a toolbox, it's a drawer to keep your data in, and you can just
weird analogy, but I guess makes sense.
Label on it, and you can reach in and pull out your code or whatever you want. That's like the whole entire idea. It's not that classes are some type of you hear like the factory analogy a lot, but I don't think that's really like what helps people understand like why we use them. You use classes to keep track of all your primitives, all your variables, all your integer strings, what have you. So
yeah, more or less.
Okay, so let's just say you are a programmer who has no idea what classes are, and you're having a grand old time making, what do you know, a Pokemon code. You're making Pokemon code. Your Pokemon has health, your Pokemon has scream, where it can scream Pikachu. It can kill a Pidgey if it wants to, because we all hate Pidgeys. And I'm just kidding if you're a Pidgey, if you were like one of those weird people that like Pidgeys, but it also has an experience, and you're having a grand old time in your app, but then you start realizing like I can't keep track of all these functions and put them all around in my app. So what do? You create a class, you call it Pokemon, and you just put all that stuff in here. Like that's kind of like the whole entire idea. This is your toolbox. So you're gonna put your EXP, you're gonna put your health, then you put your function down here, just like that. And I'm running out of room, but you get the picture. And
yeah,
what happens is that you have a nice little briefcase, toolbox, drawer to keep all your data in, and whenever you need your data, all you have to do is type in var Pokemon is equal to new, and then you can new up a piece of data. You can new up your Pokemon without having to keep track of all your variables and all your health and your string and all of that. It's pretty neat. Not only on top of that, but let's say like you want to use this Pokemon everywhere, and then you start realizing, hey, like I have a Pikachu that I'm using all over the place too. What you would do is you would do the exact same thing. You would create a class,
another class, and explicitly type it. I think there is a better way to do it.
And then you would extend it so you can use all your previous Pokemon code, and you don't have to actually worry about recreating the health, because all Pokemon have experience, all Pokemon have health. All Pokemon want to kill Pidgeys because we all want to kill Pidgeys, but in this case, Pikachu has
more
classes
health
of its own. Let's just say,
and does have classes of its own also.
Electric. Use electric, and you call that function, and you go in there, and you have that function there because this is specific to Pikachu. Not every single Pokemon is going to have use electric, and that's the reason why you would extend it, and you still get all of those. But let's go in, let's create a class, and I'm going to show you a very important concept of why we, what happens underneath the hood when we actually use create classes. So I'm going to go in here, and let's go ahead and create our Pokemon. So I'm going to have health, and it's going to be a number. Then I'm going to initialize that number to 34.
Okay, he's doing both. Initialize. I guess you cannot leave it vague like you do. Probably that's why you use interfaces.
Good. And then we'll put function kill Pidgey. So health is equal to a string, and our string is good. And I'm gonna call this one experience. So I'm gonna go experience and then health, and then go down here and kill Pidgey. And console.log
Kill Pidgey.
Pidgey. Killed. Pidgey dead. And I'm gonna take out that function.
Okay, you can type it without the function, sure.
Here, what we're going to do is, let's go ahead, and I'm going to new up this object, and we're going to see what it looks like under the hood, because this is kind of important to understand like what's happening. And then I'm going to go under here, and I need to create called a joker value. I'm going to call that joker because we need to have an extra value down here so we can see like what's actually happening
before it, yes.
So let's go here. Let's go ahead and let's run our debug. You don't have to do this if you don't want to.
We left something in the oven.
But what this is going to do,
thank God nothing got burned.
Inside here, now you can see all of your values, and it's an object. When it's just this, it's literally just a 0, but when you have an actual object in here, you can have more than one. They can be different types, and they hold your values there. If you just look at that, and you can always tell. And this is not stored on the stack. This is the call stack. This is actually, objects are stored on the heap, and I talked about that in my previous video. But let's go ahead in here, and we're going to create our class Pikachu. So we're going to go Pikachu, and it's going to be the same thing, and we're going to have the use electric, and console.log use electric, and go in here. Okay, so, and let's just give it a nice little property for good time's sake. And
you didn't do the extend, so I do not inherit any of the attributes of the Pokemon class.
So we're going to go Boolean, and we're going to say Pikachu does have a tail. Some Pikachus might not, though. You never know. Okay, then what we're going to do is we're going to extend this Pokemon. Extends Pokemon.
So what basically TypeScript gives so far is the inheritance and the type checking of other programming languages. Okay.
We'll have our Pikachu, and we're going to lowercase this, and we're going to call this Pikachu. Okay, so let's go ahead and run this, and let's see what is inside of our Pikachu and see if we actually extended it. So we're going down, and we're going to hover over it, and would you look at that, we have experience 34, our health is good for our Pokemon, our health is good, and our Pokemon has a tail. And not only on top of that, but you just learned what inheritance is. I hope you just
nah, that's inheritance.
All the way through, because you just learned like a bunch in like a little bit, but you may have known that already, who knows. But I hope that you guys enjoyed this video. If you did, make sure to hit that like button, make sure to hit that subscribe button, and
1, 2, 3, 4. So probably you'll be able to finish TypeScript by tomorrow. Apparently, from what I've seen so far, TypeScript isn't that difficult. Angular, on the other hand, will probably be more difficult. But let me check how the projects of Angular projects. Just want a simple one for a web application, just to see how everything goes. Let me check the first ones. This one is making a game. 18 projects. I want to see the website. That's probably the website. Okay, the one that we'll have in mind is probably for our to-do list. User management system. From what I've seen, it doesn't take that much to do them, so I'll probably try to do a couple of them. Okay, but we will stay with Angular for around a week or so. But since I probably have a background with React, so it shouldn't be that difficult. I even checked the documentation for it. It wasn't that long. So I guess that will be it for today, guys, and thank you for watching.